Good morning, boys. We'll revise some of the basics of communication protocols used in embedded systems. Okay. Hello?
Yes, sir.
Okay, thank you. Boys, can you tell what is a communication protocol? Anyone? What is a communication protocol? Hello?
The set of rules used for communication, sir.
Okay. When two devices wanted to communicate, what is the set of procedures or rules to be followed for effective communication? Okay. For example, if there is a transmitter and receiver, they can connect through wired medium or wireless medium, but they will send some signal, okay, indicating the device to which the signal is transmitted. It will have some information related to where the particular data has to be sent. It will have some control information. Okay, the control information will have some unique address. That address defines to which device the data is transmitted. Also, it also defines some format.
IP address, sir.
Hello, voice.
Yes, sir.
It is not. It is address means each device may have an IP address, or wireless device it will have, so it will be configured in such a way the transmitter can identify that particular receiver device.
Yes, sir.
In order to identify the device, the transmitter should have already an idea about what type of devices it is going to communicate. Okay, and similarly, the receiver sends an acknowledgement signal. If the device as the transmitter, if it has sent an data, the receiving device also will send an acknowledgement signal. Okay, so there will be signal exchanges between the transmitter and receiver. Okay, sometimes it may be half duplex, sometimes it may be full duplex also. Half duplex means one at a time. Full duplex means transmission and reception simultaneously. Okay, so voice communication will be always full duplex, but data communication sometimes it is a store and forward type of technique. So in that case, you need to also check about the error checking mechanism. If any error has occurred, so there should be some possibility of retransmission of signals also. So the protocols define some of the procedures to be followed when two devices are going to communicate. Here we are going to discuss some of the basics of embedded system communication protocol. So basically, in embedded system communication protocol, the physical layer, which is the lowermost layer, is associated with the signal transmission. What are the important parameters that need to be considered for signal transmission is we need to know about the signal amplitude, we got a signal strength, and then the signal exchanges between the transmitter and receiver. And bus arbitration means procedures need to be followed if there is any conflict in the data transfer, if there is any problem, how it can be resolved. That is called as bus arbitration. And then identifying the address of the device to which it is going to transmit, which is called as device addressing. And the transmission can be both wired or wireless. So accordingly, how much data lines are used for data transmission, these are all indicated in communication protocols. Particularly in the lowermost layer, that is the physical layer. The top layer, application layer, deals with what is the speed at which the data is transmitted and whether the transmitter and receiver are agreeing upon some common standard formats. We'll basically have two important classifications of protocols in embedded systems. One is the inter-system protocol, another one is intra-system protocol. Okay. You have any idea about what is inter-system protocol and intra-system protocol? Hello? Boys, can anyone tell what is an inter-system protocol and intra-system protocol? Hello?
Yes, sir.
Any idea about inter-system protocol or intra-system protocol?
No, sir.
See, when there are two devices, if they are very far from each other, okay, the distance involved is a longer one, okay, and if you are going to use a communication medium for connecting these two devices, then a communication protocol used for connecting two devices which are far from each other, it's intra-system protocol. Whereas an intra-system protocol is on board, within the board. If you are going to establish communication between the devices, it is called as intra-system communication protocol. Okay, one is between the systems, other is onboard a system when you have multiple devices, and if they wanted to communicate with each other, then it is called as intra-system communication protocol. Examples for inter-system protocol is, for example, controller, a microcontroller, a microprocessor want to send a signal to a sensor device which is at a remote place. Then accessing the sensor information from the remote place can be achieved only with the help of a wired medium. So communication between two systems, when their distance involved is long, is inter-system protocol. How we are going to communicate between a PC and a development kit or any other actuator device or sensor device, if the field devices are going to be very far, then it is called as inter-system. What is intra-system is when you have a board, when you have devices which are very close to each other, and if they wanted to communicate, then it is called as intra-system. For example, in a motherboard, any PCs or laptop PCs, then you will have many ICs which will be very close to each other, and if they want to establish communication between them, then it is called as inter-system communication. Okay, IC to IC communication on board a system is called as inter-system communication. Example for inter-system communication.
Okay, sir.
So inter-system communication protocol between two communicating devices, okay, with the help of a wired medium. So we need to have conducting lines, buses for transmission of signals. That can be achieved only with the help of this inter-system communication protocols. Examples for the inter-system communication protocols, some of the important communication protocols used for inter-system are the universal serial bus, USB, and UART, which is nothing but universal asynchronous receiver and transmitter, and USART, universal synchronous asynchronous and receiver and transmitter. Out of this USB is widely used in all the products, from desktop PCs, laptop PCs, or the electronic gadgets, because it is a very simple protocol. It requires only 4 pins for transmission, D plus and D minus, which are differential data lines, and then a supply pin and the ground pin. We'll see some of the basic features of USB. What is the communication format in USB also we'll see. It's a simple two-wired serial communication protocol. So each device in an USB bus will be given an address. If it is defined by 8-bit address, then we can have 2 power 8 combinations, and so up to 127 devices can be easily connected. That is how each device will be recognized or identified. And USB supports plug and play functionality. What is plug and play is it derives the current from the host device itself. Once it is inserted, and it can be detected on its own because it will have a device driver routine, or we call it as a controller, host controller. It automatically configures and it is ready for communication instantly. Most of the electronic gadgets, they are provided with this universal serial bus interface. They support this differential data transmission, which is D plus and D minus. With the help of these differential lines, the data will be transmitted. The advantage of this differential data line transmission is the noise will be very less. Noise effect will be very less. So it is a balanced transmission. Apart from this differential data lines, 2 important pins which are used are the supply and the ground line. USB or self-powered devices, they will, once they are connected, they will draw the current from the host itself. USBs can support various types of data transmission communication, synchronous, asynchronous, and isochronous data transmission also. Very simple communication protocol with only just 4 pins. And then now the format of how data is transmitted in USB. In USB, the data will be transmitted in the form of packets. A packet is nothing but a group of bits. Each data packet will compose of 8 bits, that is 1 byte, with the least significant bit, that is D0, that will be transmitted first. And USB, it supports some encoding schemes. What is encoding scheme is the format of how you are going to represent the binary ones and zeros. USB uses non-return to zero inverted. This non-return to zero is nothing but how, with respect to reference line, how the data format is represented. We'll see the data format of how USB supports packet data transmission. This non-return to zero inverted coding scheme synchronizes the host system and the receiver clock signals. So the format will be like this, the data format in USB. So non-return to zero inverted coding scheme is represented. We see that this format will have, you have to indicate the date of transmission, start of transmission. It is indicated by start bit, followed by 7 bits. So the least significant bit is transmitted first, and the most significant bit is the bit 7. At the end of data, then to indicate that end of packet, it is indicated by 2 stop bits. An additional parity bit will be used for error detection. So totally we'll have 11 bits per character in order to transmit the data in USB. So that is the data format in USB, how non-return to 0 inverted coding scheme is used for transmission of signals. Some of the basic advantages of USB is a simple communication protocol, but fast, low cost implementation, and plug and play option. So these are some of the advantages of USB, and disadvantages of USB. When we consider, it needs a master device which can source current. So it needs a powerful master device, and specific device drivers routines to be implemented, because only because of these device drivers these USB devices are able to identify, and then communication can be established. Each USB device will come with a device driver routine, and so that once we connect it, the device driver will be installed in the host controller, and the data is ready to be transmitted from the host computer. That is why these device driver routines are required in universal serial bus. Next is the UART communication protocol, which is an asynchronous communication protocol. This IC will convert the parallel data into serial data. Because microprocessors or microcontrollers can process in parallel, and the parallel data can be converted serially only with the help of this UART IC. There will be a buffer. If a microprocessor or microcontroller wanted to transmit a data, that buffer will hold the parallel 8-bit data, and this parallel 8-bit data will be converted by a UART IC into serial and will be transmitted serially to the remote device. It's a simple protocol which has 2 pins, transmit and receive pin, for transmitting serial data and receiving the serial data. So UART means there is no clock signal associated with the transmitting and receiving end. Instead of clock signal only, there is indication of data transmission is by the start bits, and the end of data packet is represented by stop bits. UART basically detects the start bit, and also it defines specific speed at which the data is transmitted. The mode of communication in UART is half duplex, meaning only one at a time. That is, either it can transmit or receive. That is called as half duplex mode of communication. Next one is very important, USART communication protocol. It can support both synchronous as well as asynchronous mode of communication. Synchronous means with respect to system clock. So in USART, it generates a clock signal which can be recovered at the receiver, and the data can be transmitted without knowing the speed at which the data is transmitted. The UART and the USART can transmit and receive in half duplex as well as in full duplex mode, depending upon the application. Some of the advantages of USART is the clock signal is not required, so there is no need to know the speed at which the data is transmitted. Very cost effective because it uses only 2 pair of wires, and then uses parity bits for error detection. The main disadvantage of UART or USART is it doesn't support multiple master slave functionality. So only one master and one slave device. The speed also of a communicating UART will be very less. So in order to overcome these types of drawbacks, we go for intra-system communication protocols, but intra-system is limited to devices communicating only on board. So intra-system communication protocol establishes communication between the components within the circuit board itself. In an embedded system, there may be multiple devices or multiple ICs. If they wanted to communicate with a processor, then these type of intra-system communication protocols will play a major role. The only problem is when the number of ICs increases, it leads to increase in power consumption. But intra-system communication protocol ensures secure data transmission between the peripherals. Some of the important intra-system communication protocols are I2C, integrated circuit communication protocol, SPI, which is serial peripheral interface, and CAN protocol is controller area network. These 3 important protocols are used for intra-system communication. First, we'll discuss about some of the basics of I2C communication protocol, which is inter-integrated circuit communication protocol, serial communication protocol. The main purpose of this inter-integrated communication protocol is to provide easy communication between the peripheral devices with a microcontroller. It uses 2 wires for communication. One is the serial data line and the serial clock line. These 2 wires are bidirectional in nature, meaning they can communicate to and fro. In both directions, they can transmit the signal. I2C is based on master-slave communication. Each slave device will be provided with a unique address. I2C communication can be established only when the master device sends a target slave address. And once the slave address is identified to which slave address it is being transmitted, the particular slave device will move into active mode, and so it is ready to receive the signal. This is how the master and the slave devices are able to communicate with the master initiating a request, and slave will respond. The slave device starts to communicate once it is brought to the active state. And once the signal is received, an acknowledgement bit will be sent by the slave device to the master. The serial data line and the serial clock line of high to low transition at the start condition and low to high transition at the stop condition is given. Some basic advantages of I2C communication protocol is I2C supports communication between the onboard devices which are accessed infrequently. The addressing mechanism is very simple, and so it will ease the master-slave communication. The cost and the circuit complexity does not end up on the number of devices. When there are more number of devices, the circuit complexity will not be too much because number of wires required is less only. Plus, the speed will be very less. The disadvantage of I2C communication is its speed is limited. Next one is the serial peripheral interface, SPI. Compared to I2C, it requires 4 wires, master output, slave input, and master input, slave out, slave select line, and the serial clock line. SPI is also master slave communication protocol. The master device first configures the clock. After the master device configures the clock at a particular frequency, each slave device will have a slave select line, and accordingly the slave select is given an active low state. Then only communication can be established between the master and the slave device. Serial peripheral interface can support full duplex communication, and it doesn't limit the data transfer to just 8-bit words. Continuously it can transmit. How a master is able to communicate to the slave devices can be seen like this. So you have a master communicating to 2 slave devices, and how it is going to select based on the slave select lines. So SS0 and SS1 are the slave select lines for the slave devices 0 and 1. Similarly, the clock will be running for each slave devices. Master output, slave input, master input, slave output, and slave select line and a clock line. So 4 lines will be used for communicating between the master and the slave devices. When there are more number of slave devices, and so more wires will be running, so it leads to circuit complexity. The advantages of serial peripheral interfaces: it is much faster than the asynchronous serial communication protocol. It supports multiple slave devices to be connected simultaneously, and it is an universally accepted protocol with low cost implementation. The serial peripheral interface will involve more wires than other communication protocols. So the master device to control the slave communications is effective, but the slave to slave communication is not possible in SPI communication protocol. And when there are more number of slave devices, the circuit complexity will increase. Next, another important communication protocol is the CAN. It stands for Controller Area Network. This protocol is used in automotive industries to connect various modules in a car. It requires 2 wires, CAN high and CAN low, H plus and H minus for data transmission. This protocol is a message oriented communication protocol. And the advantages of CAN communication is very reliable communication protocol with low cost implementation, and secured and fast communication protocol, but is used only for automotive industries and a bit complex protocol. So these are all some of the communication protocols used in embedded systems. We need to know some of the basics of these protocols, where they are used, and their advantages and disadvantages. With that, I will wind up and